Hello, everyone. My name is Constantine. I'm working as senior Android developer at DataArt, and DataArt is platinum sponsor of this event. Also, thank you, GDG, for organization of this. And we'll talk about what it means to be reactive. I mean, RxJava. In context of Android, but more about Java. So, looking at reactive.io, we can find some definitions that talk about asynchronous nature of RxJava, about that it makes robustness of our solutions, and a lot of text that you can just Google and read in the reactive.io. And on the DroidCon in Berlin in this year, Ivan Margila, author of the maybe first book about RxJava for Android, said a lot of times, it's a piece of cake, you know. It's a piece of cake. So let's go. Let's look at this piece of cake. You can see Ivan Margila, who wrote a book. One of the first founders of RxJava was Eric Meyer. He participated in the great course of functional reactive programming on Coursera with founder of Scala, Martin Andersky. It's a great course, but it's not useful for Android developers, I think. Ben Christensen, whose team created RxJava in its nature for Java, and Jake Wharton from Square, who made a lot for making it suitable and useful to use RxJava for Android, because Android has some specifics, you know. Let's talk about fundamentals of RxJava. Let's relax. Everybody ate here on the lunch, so we can relax, we can stop, we can think about the world around, about the stars that we are looking for, and understand that everything we see or feel here is a stream of some events or data. For example, we gaze the stars in the heaven and we see them because a stream of light that is coming for us. It's not a static data as collections, it's a stream. We can stop death of the star because star dies somewhere and we just receive this event and observe it here on the Earth. So one of the main parts of the RxJava is working with streams. So we work not with static collections, but with data that changes without our influence on them. It's very important for next pieces of code. The second part is that when we listen for something, we are observers or listeners. And there is a great book somewhere below, had first design patterns, or maybe an original book about design patterns that describes a pattern observer that says that there is source of something, a subject, a source, observable in terminology of RxJava, and there are listeners, and listeners can be a lot, but source may be something unique. Usually, listener in Android looks like this. We have a class, maybe anonymous class, instantiated, and making something just when this event arrives. Pretty simple, it's a piece of cake. I will use lambdas because I use retro lambdas in my project, so if you see such notation, just don't be afraid. Raise your hand if you used lambdas for Android. Okay, pretty much amount of people. Great. So if you have a question, just ask it later about lambdas. Observable and observer. A lot about these things, but they are basics. I will tell you a theory later. Now we will look just how to do it. Here you see a basic creation of observable, and this is a source of events. How make events, and how these events can be asynchronous. We use observable create static method, like a static factory method. Let's take a subscriber. A subscriber is someone who will listen for our events later, and give him some commands. For example, on next. Here, subscriber. We just receive it, and we'll receive it on the moment of subscription, and give him a data on next, on complete, or on error. He will see it later. So on next means that we generate some event and say, oh, here next event comes. Let's go next. On complete, it says that stream is completed. Our events just came not only in the collection in their material order, but also in the timeline. So we can put somewhere here some thread sleep, for example. Make it asynchronous set, and it will work. So it's not just a collection, it's a collection of data, for example, from some thermometer. So one note, there is also observable in Java utils. So when you bind your RxJava library to your Android project, don't write blindly observable, because it can be Java util. Unsubscribe. Unsubscribe is a callback that just implements our logic of observable. And here is it. I already told about on next and complete. What is observer? It's a listener, simply listener, as it is in usual Android, like on-click listener that we saw on one of the previous slides. But this listener has not one, but three callbacks. These three callbacks realizes the great thing of Rx. They make us know what exactly happens, not only a piece of data, but also such thing as, is our stream completed? Because we are listening, we are not working with the static data. We should know when our data will be finished. So sometimes we will wait hour observing events, but then the end of the stream will come to us at the moment. The error on error means obtaining an error result. Framework RxJava will automatically generate for us on error call if something wrong happened in the observable. Make a note, this is observer, this listener. So framework helps us not to write a lot of try-catch code. I will not write it here. It gives us a callback, and it's RxJava makes for us all. And on next, you already know, it's just a listener for our data. And here are highlighted these three callbacks. And one more piece of code for making magic. They just will work only if we will make a subscription. A subscription is also the class of RxJava, and subscription makes us controlling the fact of listening to the events. I mean, call for subscribe will join observable and observer, but subscription will give us ability to make such thing. It's very useful, for example, for working in activities in Android, because when we destroy activity, we will not lead to memory leak. We should unsubscribe. We should close all our connections. We should not keep the reference to something in memory until it's already destroyed. Okay, so we joined everything, and we can, you saw a lot of boilerplate here, a lot of code that we will use, but using lambdas it looks better. You can make subscribe and put there not a different callbacks and not different classes, but put simple functional style one-line expressions that gives us the same logic. So if you know which is type of this integer or throwable, we usually know what we are putting into stream. We can just write it in lambdas and it will be more readable. So don't be afraid of a lot of code, just use something useful. Summing up the basics, we will come to four main parts, four main meanings of the Rx. What it means, reactive systems are at first responsive. It means that, especially for Android, we will not freeze UI until our stream is downloading data from the network or reading files from the file system or something like this. We just need to make it asynchronous. It's good with loaders, with async tasks, but here we have just a framework that will implement everything, all threading and all the things that are in async tasks, but in one place and very, very short. It's scalable. This illustration shows that we can join, like in Scala, our functional operators into one line or into one chain. So we can filter or mutate the stream for our purposes, not just in place, not decoupling it in all classes, but writing it in one line. You will see it later. It's resilient, it has on error, and already catches all exceptions, and it's message-driven. It makes the same thing as even bus. So yes, even bus is also a good thing, but it gives us ability to send messages that are divided into timeline, so not only in material space or sequence. Yes, you can read more about this here. Creating observables, even from air. Yes, RxJava gives us a great freedom of creating things. Really, we can use collections. Remember, collections are static and streams are dynamic, and also streams are functional. We can use observable from. It's very simple, it's great. Just take a collection, generate it somewhere, and just make from. We not need to use observable on create or observable create. Just convert it and subscribe to it. Just great thing, it gives us ability to put there some values, for example, and just push them into stream, or just use some function that will be called and will return us a result. Pretty simple, a piece of cake. Great thing is working with time, because our stream is not a collection. It's two-dimensional. It's not only space, it's also time. So we can generate some events with interval. Without any timers or anything else, we just call interval, put a value for the time interval and units in time unit. In this example, it's hard to read maybe. Here we see that our time, t, is converted into tuple, into an array of two values. One is the time, the moment at which we receive the event, and another is some random number. We limit this by 5 events only, and print values from this tuple. Adjusted, you will see a lot of such functional style here on slides, because RxJava brings us ability to write in functional style like in Java 8 and Scala, but using usual Android. Okay, so from can be used for creation. from collections. But we can use also network. For example, retrofit gives us a subscription that is not only that can be not only asynchronous, but also can be in observable style. So you just subscribe for list wrappers. List wrappers is just a function that will call for server and return. And who uses retrofit? Great. So maybe you know how it works. Okay. So we just can write in such functional style with retrofit. It's easy. Rex bindings. Recently, one of our GDG developers said that yesterday was release of new Rex bindings. So let's check what comes there. But at the moment I prepared this presentation, there was such thing as subscription for UI events. You can create events from just clicks on the button. And why to use this if we have usual listeners? I think only because we can use such things like debounce or sample. It's a functions that filter time. For example, a lot of times we had written a code when we should filter clicks and not give user ability to click it triple at one moment and start 3 times one function. But here is a Rex function, Rex operator debounce that will filter clicks. If we will click faster than in half of a second, we should just receive on the output, on the subscribe, only one event. It's good. And it's simple in writing the code. Filtering and conditions. You already saw time filtering, but also we can use some other filters. And we can convert them into the blocking collections. It's a great question because usually we write in functional style with RxJava and think that it is asynchronous and we should always use subscribe and put there some on next, but it's not such way. We also can use blocking observable, that is part of standard RxJava, and we can just use such operator as to blocking. And we will receive some first value, for example, or default value. And the logic is we can apply some, for example, mathematical function from plugin MathRx and map some values. Is a kind of filtering. In this example, we see that there is some collection of classes, of objects that store 2 values, not 1. But we can get some value from this collection using a functional reference. It's a feature of Java 8. We can give this just 1 values of this tuple because map will convert it. Give this to mass observable. It will count for us maximum in the functional style without loops, without for, and then just return it right here in place. Not use this in code. It's bad style. But if you want functional style, you can use it, like for collections. You can use first to default. I already said it can take a first value or just check whether our stream or collection contains values. If not, it will return default value. No if, no else, everything simple. Take. Here you see pretty simple and good readable operator take last. And you probably know what it means. Take last value. Take last 5 values. So we just define what really we need and do. You already saw first or last or default. Also you can get from the stream single default. Here you see not blocking collection, not blocking observable. Here you see usual observable that is generated by the range. Range is great operator that gives us ability to create range from 0 to 0 or from 0 to 10, for example, it gives us answer for the question, is there a single value? For example, from 0 to 0 should be single value. From 0 to 10, not. I think it will return -1. And you can use such shortcut for each. Sorry for messy a lot of examples, but RxJava is very rich, so I just try to shorten my talk. The idea is sometimes you don't need to write subscribe. Sometimes you need to write just some kind of but for asynchronous events that come to us and not exist without our listening. And not to handle all callbacks like on next, on error, on complete, we can just put there for each. It will call on next and receive a piece of data or event and make some logic with it like this. The same thing, but with max value. That means that there will be not single value. And it's not empty because the range contains some values. But if we will put there 0 value or something will not come to us, we will return 99. And it would be default value in case of empty. Sorry, it's really boring, I know. Iterable, also boring thing because we don't use collections, we use asynchronous. But if you want to use collections, convert to iterable and use the same things, the same for where is it now? For just convert into iterable. Great thing. We can gather data from some sensors that are coming asynchronous, then limit them, receiving 5 events, for example, then convert it to iterable and work with it. For which I already told you, take until it's like some skateman who is skating on the short board that will end sometime one day. So he's skating and then falls. And here is take until. It just waits, receives values. For example, here you see a range from 0 to 10. It will receive it, but when value will be 5, it will stop receiving. It will not unsubscribe, but it will stop receiving and return only these 5 values. Other values will not be handled. Contains. The same as single, default, contains. If we contain value of the, if our stream contains such value, we can find it in the stream. Remember, it's not a collection. It's not collections find. It's just a functional operator. You can put it into the chain or not to put. Filter. The same as contains, but using some logic, not only value. Simple, functional debounce. The great thing I really like because it gives us ability not to read all of this code, but to show that collection the stream should be handled with some time intervals, and only the last value will be taken. Great, and we can read this code, but don't pay attention. Sample. Almost the same as debounce, but great difference is that if debounce receives events 1, 2, 3 in the sample time, it will provide on next the last value. But if we use sample, 1, 2, 3 sample will just select value in the interval, not from the scope, but from exact interval. So it's not the same. It's like readings from the sensors. Very useful for some live data. Merge and combine. Merge. Sometimes we have not one, but multiple sources of events. sometimes we need to join them. Obviously, we can use some to-blocking operation and then to make a lot of stuff, but RxJava gives us ability to merge them directly. Just each first will step one by one, each second, and once more, and just look at this example and you will see how it works. It just joins without rules, just merges everything. It can merge even integers with strings, no type checking, just everything out here. Events from anywhere.
What is the type of item in this case?
Great question. I think here is string, because if you look here, it will be converted to string anyway. I think when you will receive data, you will check check the type anyway, because if you will try to call, for example, get current or get maximum on the string, it will crash. So you will receive the type from the original observable, but anyway you need to check.
So for each instance, the parameter actually one of some type. That's what I asked you. What is parameter?
I think here is implicit conversion. So here works to string. About more complicated example, you are right. It's pretty interesting. Let's practice after this talk. Okay? Zip. Add to types, additional check. Just joining two streams and then apply some rule for combining them. And you will see that our join now contains not 5 plus 5 items from two streams, but 5 items joining each one. First with 1, second with 2, and etc. So here the type is defined exactly. Error handling. You know there is on error, and it's great. It really solves our problems with try-catch. It really makes our life easier. But sometimes we need to request some data from the network and then handle some error. Retry with another parameters. Try once more, try with timeout. Change timeout of the rail connection, for example. And here comes retry. Retry is an operator, a great building block which makes scalable RxJava, and it really gives us ability to check to check what really happens and how much times we should handle error. Here you see example. We have the stream of integers, but on the third integer we will throw error of the type error. It's our defined type. And on fifths we should throw the throwable. Look here. Here is logic that shows that if we failed once with throwing on error, on the next time we should not throw it, but throw another error, 5. So just stream looks like integer, 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 error, integer, 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 throwable. This is created just to show you how to use retry. Retry gives you ability to take a value, for example integer, and take an error, and make some logic built upon these values. So we can check whether our error is instance of error, or network error, or Stack Overflow, no. Some kind of error. Yes, we can check it and return Boolean that will show us should we retry or not. So stream will retry to connect, retry to subscribe, and then just go forward. Look here. We return true only when it is error. If this logic will meet throwable, it will fail. It will not retry. we can control the flow of even error handling. And here you see example of what happens on the third error. We see error, first retry, and then we reconnect. The stream goes successfully until 5 value, and then just fails once more and return null because there is throwable without any definition, without message. Math and aggregate. You already saw Math Observable. It's a plugin for RxJava. It's not built into, and it gives us the ability to count maximum. Simple. The same is about average. Something similar is reduce. It's like take A and B, make a sum, and return this value for the next value. So reduce gives us the ability to fold the stream and make it, maybe fold it in one value even, just using some rules. It gives us the ability to control a result of such operation in reduce on the next step. Subjects. These ubiquitous mediums act like actors and can play any role. They're really fine. They are created the same way as observable. So it's the sources, but by the way they can act also like listeners, observers. And we can create them with some size. I will show you why. It's just example of code that will show you some logic. Just look here. We have some events that happen before our subscription. Then we subscribe to our subject. And then we have some events that happen with our subject after subscription. So pretty simple. And then subject can also be called with uncompleted. Publish. Just publish everything that comes to it. Async just returns only one. He's like Twitter. He makes tweet one time on the subscription and then doesn't repeat anything. Behavior, like a diver. He make one breath. Depths and flows exactly like a published subject. The idea is, you see, here will be returned one after. He will be returned everything after. He will be returned one before. Behavior subject remembers 1 hour event that happens before subscription and replay. It should replay everything it remembers or the stack that remembers, for example, 2 events. You can check how it works on the reactive diagrams. They're great. Schedulers. Okay, we have not enough time, so schedulers are just one piece of Android Rx Android that is written by Jake Wharton and gives us the ability. Sorry, there are 2 schedulers. Yeah, there are schedulers from RxJava and from Android. RxJava scheduler on make scheduling of the threads, so we can make async threading for some kind of operations like file operations or networking or something like this in proper way. In functional style. Computation. One more. Oh, okay. So we will try to change value, set text on text view, and obtain such error. Sorry, I will tell about Android a little bit, but yeah, the thread that created the view should only change it. So here comes Rx Android, our topic. Is just another library. It's not RxJava. And on the GitHub, you will see that use simultaneously RxJava and RxAndroid, because RxJava is developing very fast and RxAndroid was done and not developing such fast. But we can put scheduler for Android in observe on, and this will not fail. It works like handler or call on main thread, but we put subscription and observing rules for trading just in simple functional style. It's great. It not makes us to write a lot of code. Activity lifecycle, I think, just remember to unsubscribe when you destroy your activity. It's about configurational changes. And not only this, because probably you will read Matt Dupre, which has a lot of, journey comes to end. Where to look? You can use these QR codes, or just remember that there are a lot of sources on RxJava. There are a lot of sources like additional reading on GitHub. There is a great book of RxJava Essentials by Ivan Margila. Also, this year, there is a book made by Matt Dupre that is even better. Sorry, I not mentioned it here. And in case if you don't understand that awful things with merge and other strange things with multiple observables, just look at Rx Marbles. Here are great diagrams that gives you ability to change, to drag some events on the timeline and see what happens there. So I think it's great for start. Additional reading, okay, it's not useful. Thank you very much. 5 minutes? Okay. So, questions, please. From the up? Yeah. I'm sorry, I heard just about an activity lifecycle on Android. I'll answer, and then?
Second answer is I use some operators to take a map, flat map, and if I use so much that operators, is that impact on performance?
Okay, let's start from the end. Any operation you do takes some time. So if you want to do in half an hour all of your work that you planned for 8 hours, probably you will fail. So when you join your operators in the chain, it evidently impacts performance, but use them with conscience. Just put only those operators that you really need. Because RxJava gives you a lot of operators, functional blocks, that makes work of another, I think, multiples. So you can just simplify it, and every simplified operator is already optimized by Netflix. So if you can use, for example, average from math observable, it will be faster than reduce that you will write by your hand. About activity lifecycle, it's a great question. At first, read Matt Dupre. It's really great book. It tells a little bit more than Ivan Margila. But anyway, there are 2 rules. The first rule is to unsubscribe from events, because you will not listen for events when your activity is destroyed and you can dispatch them on the UI. And the second one is to use such hacks like replay and cache. I didn't told about this, and probably it will be in another speech somewhere, but there is cache that gives us ability to store our observable between destroys of it. So if our activity will be recreated, it will just take it from the cache in the system and not create it once more and not make one more call, which may be long. Replay gives us ability to remember the last values. So you can, after recreation of activity, just take the values that you already downloaded in separate thread when activity was not created. Also, there's great solution from Jake Wharton. It's a left cycle observable. I'm not sure that it's part of Rx bindings, but probably you should look in the direction of Rx bindings, because there is observables that will handle activity lifecycle automatically.
Are there any possibilities to set server priority or to group servers by priority?
What do you mean by priority?
For example, if I want some documents to be handled first in one place and after that only to be handled in another place, or to be concealed other such concepts.
I just don't understand about priority.
For example, to unsubscribe other servers.
To unsubscribe others, we can use compound observable, so we can just put everything in one observable and unsubscribe in a bunch. About priorities, maybe it's something like zip. You can just put a logic there and then output the result in some one stream, but with priorities. Is that one? Maybe, yes. Evgeny?
Sorry, it's last question.
Okay.
Okay, everything have its price. So what should we pay for when we are using RxJava? Or RxAndroid, RxJava, anything. So what are the disadvantages of, or maybe some kind of issues that are currently presented in RxJava and RxAndroid?
Great question. The first is, it's not simple. I understand that here are Google developers, and you already know what is lambdas, what is functional programming, what is Java 8. When you invite to the project some junior developer who maybe don't know such basics, it will slower your development very much. So don't use RxJava where it is appropriate. So use it with developers who will not say, oh, it's unreadable, don't use it. Use it with, in teams where people are ready for this. I think there are a lot of developers who like functional way, but there are a lot of developers who don't like. And it's okay to write everything in simple, pure Java style. Absolutely. Another disadvantage, use it carefully in Android because you need to know how to handle activity lifecycle. Because it will lead to memory leaks if you use just a code from my presentation. It's just Java code. That's all.
Thank you.
So thank you, Constantine.
There are prizes for...
For best questions?
Yes.
Oh, okay. So whom do you want to?
I think there are 3 best questions. So let's start from the end. Should I come to person? Evgeny? The last question. Throw? Okay, thank you. The second said, don't burst with any reactive things, just feel your warm. So the second question, the person in the, yes, with a beard. And the first maybe it's such beautiful notebook from Data Art. So the first question was there, the young man in OMG hoodie. Okay. So, thank you.
Okay. So